Learn how to use an Uint32Array view to safely store and retrieve massive whole numbers within a raw binary array buffer. In this example, we want to look at how you can use the Uint32Array view to layer data on an array buffer. The Uint32Array view slices your buffer into much larger 4-byte chunks, that is 32 bits each of memory. So this extra binary real estate allows slots to comfortably hold massive numbers up to over 2 billion. So let's look at the example that we're talking about. So the first thing I'm going to do is I'm going to make my buffer variable, and then I will assign it the new array buffer constructor, and then pass it a memory block of 12 bytes. I just created a buffer with a memory slot of 12 bytes. So now it's time to overlay an Uint32 array view on the buffer. So how do I do that? Well, let me just call this view. Then I will call the method the Uint32Array. I passed in my buffer, which is my digital real estate space. So now it's time for me to write or set values in the view. So let me just write. So I want to write massive 32 bits sign integer to the buffer, integers to individual index positions. So I want to write to the index position of my buffer. And how do I do that? Well, I'll call this view, that is, whatever is gotten from this, I want it to be saved inside my view. So I'll call the first number. Let me call this maybe 10,000. 1, 2, 3, 4. And then the next one can be like 20,000. And finally, you can have 300,000, sorry, 100,000, 200,000, and 300,000. So with what I have here, I can go ahead to read the values back from the view. So what I have from that view, I want to read them, and I will just make another variable. I call it v0, and then call view1, view2, and then view3. View0, 1, and 2. So this I am reading from this buffer that I have up here. So here I wrote to the buffers with these values 0, 1, 2 with the values of 100,000, 100,000, 200,000. Now I'm reading that values out back from the view or out from the view. So I'm assigning them to another individual variables to carry the return value from each of what is written in the buffer. So you can see v0, v1, and v2. So these are the variables that will hold the expected output from the right part of my code. So now that I have this, it's time for me to go ahead and display results. So we'll move forward and call on document.getElementById. Demo.inner HTML equals to values and plus v0 plus v0, v1, and v2. And now if you look at the screen, You can see 100,000, 200,000, and 300,000. Now, this example simply shows us how a 12-byte array buffer is wrapped inside an integer 32 array view, because each 32-bit number requires exactly 4 bytes of space. So our buffer is perfectly divided into exactly 3 usable slots. So 12 divided by 3, that is 4. 12 divided by 4 bytes per element, that is 3. So you can see what we have here, 1, 2, 3, to represent our buffer. So if you look at the what is it called? If you look at the raw bytes inside my buffer here, now after this script run, so the index position takes up bytes 0 to 3. So index 1 takes up bytes 4 to 7, and index 2 takes up bytes 8 to 11. So they sit perfectly side by side in computer memory until it reaches the last byte that we have inside our buffer. So as it is right now, if we accidentally allocated only 10 bytes to our array buffer instead of 12, what will happen when we try to create the integer 32 array? Just think over it for a few seconds. Okay, so let's go ahead and change it so that we can see the result of what is going to happen. Let me change this to 10. Now you can see that the value has disappeared, and if you try to inspect and check the console of your browser, you can see occurred range error. Buffer length for integer 32 array should be a multiple of 4. Now, this clearly tells you that if you divide 12 by 4, that's going to give you 3. But if you look at what we have now, by the time you divide 10 by 4, now you can see that there's already a problem. You will see that immediately I change this to 12, then it should work back. Now, you can see it now. If I take it from here and put a number like 14, what do you think is going to happen? You can see it is still the same length. But if I put it at 16, this should still give me a result. Because of what? Because I still have 16 divided by 4 bytes, which means that my array buffer can still accommodate one more 4 byte space. So length is very important when working with when you are trying to lay data through a view on your array buffer, because if you give a length that is not understandable by the program, you definitely get an error, and this range error that will tell you that your buffer length for int32 array should be a multiple of 4. So once you understand the length, that is what should inform you when it comes to assigning slots to your array buffer. So int32 array, which is a 4 byte memory allocation, partitions the memory into 3 distinct 4 byte zones. So if the length does not match what is expected, there's going to be a range error, just as we got on the screen right now. So this structure allows us to write large coordinate data, timestamp, or complex calculation offsets directly into raw binary blocks flawlessly. So the browser will throw a range error exception because a 32-bit typed array requires its underlying buffer byte length to be a multiple of 4, and that is the reason why you are seeing this output on the screen. Anything other than this, it will just throw an error. Even if you put this at 20, this is still going to, this is okay. Yes, that means into 4 bytes in 5 places, because 20 is divisible by 4. But if you put this thing at something like 19, this should give you a range error. Or you put it at something like 21, that is not divisible by 4, then there will be a problem. Or you put it at 25, this should also be a range error. So I hope you have been able to see things that you need to avoid when working with array buffer in JavaScript.